Now for our next example, we'll be looking at a problem that will use several of the guidelines for simplifying radical expressions that we've talked about. And the problem is this: we have the square root of 40x squared z to the 5th divided by y to the 8th. And you'll remember that one guideline is that we don't want to leave a fraction as a radicand. So what we'll do first then is to rewrite this using the quotient property. So we'll then have the square root of 40 x squared z to the 5th divided by the square root then of y to the 8th. Now in the numerator, what we'd like to do is to look for factors that are perfect squares. And for 40, would you agree that the largest perfect square factor of 40 will be 4? So we'll rewrite then that is 4 times 10. X squared already is a perfect square. And the largest perfect square factor, z to the 5th, would be z to the 4th. So we'll rewrite this then as z to the 4th times z. And on the bottom we still have then the square root of y to the 8th. Now in the numerator, what I'm going to do is to rewrite so that the perfect square factors are listed at the beginning. So we'll then have 4 x squared z to the 4th, and we'll have then left, we multiplied then by 10z. This is all then divided by the square root of y to the 8th. And so now if we rewrite using the product property in the numerator, we'll then have the square root of 4 x squared z to the 4th multiplied then by the square root of 10z, all divided by then the square root of y to the 8th. So now if we come then back over here to write our final answer, then taking all the perfect square factors out, if you will, they'll end up then with 2x z squared times the square root of 10z, all divided by, and that denominator is a perfect square, so that will then be rewritten as y to the 4th power. And we can see that there's really nothing to cancel here in terms of reducing the fraction any further. So then our final answer then will be this.